Our third presentation, third presenter, will be talking about open mapping for urban resilience, a routing model to nearest safe space in earthquake vulnerable Dhaka by the author Remisa Maliha. This work demonstrates how open data and the free GIS tools can work together and can be utilized to support earthquake preparedness.
Hello everyone, this is Shamsi from ArcGIS. The topic I'll be explaining today is mapping resilience safeguarding Dhaka from earthquakes. Dhaka, a rapidly expanding megacity with 15 to 20 million inhabitants, faces extreme earthquake vulnerability due to its location near the active fault lines. But it has lack of accessible open spaces, which critically comprises the city's resilience, hindering effective evacuation and recovery after seismic events. So this study integrates urban resilience theory, accessibility theory, and participatory GIS and demonstrate how mapping and routing to safe open spaces can significantly reduce casualties in earthquake-prone megacities. The urban resilience challenge tackles vulnerability. The scarcity of per capita open ground means a moderate to severe earthquake would be catastrophic. Rahman, 2023. High resolution mapping of urban open spaces is crucial for disaster response as accessibility to safe ground is a limiting factor for survival in dense areas. What would the urban open spaces do? Immediate refuge, allowing people to move away from collapsing buildings, safe assembly points, reducing chaos and enabling coordinated evacuation and relief, logistical hubs, organizing temporary shelters, first aid, and supply chains. Participatory GIS, empowering communities and bridging data gaps. A global study shows that uh, in South Asia, building data completeness is only 9%, rendering entire neighborhoods invisible in official risk planning. Global evidence that open spaces can save lives. Nepal. Only a fraction of potential open spaces were suitable for emergency shelters due to accessibility and size. Existing public open spaces were insufficient during aftershock. Indonesia. Lebanon. An agent-based simulation showed that accessible open spaces allowed 52% of the population to reach safety within 5 minutes compared to 39% when blocked. Turkey. Residents instinctively moved to open spaces after initial shock. China. Public open spaces were critical for evacuation. These cases collectively prove that detecting and routing to open spaces is a life-saving necessity crucial for survival in the critical first minutes after an earthquake. Now, conceptual model, first of all, has a, as I said, earthquake need and accessible open spaces are vital resilience infrastructures that reduces casualties. Gap. Official maps and planning data are incomplete. Solution detect and verify open spaces, calculate shortest routes, and empower communities through participatory mapping. So our workflow, open space detection, verification, routing model, open space principles. Step one, data detection and filtering. We used Google Earth Engine where we collected the Sentinel-2 imagery for NDVI, and also we did NDBI, and for building data and street data, we collected the OSM data. Verification and gap management, routing model implementation for which we use QGIS as its open source app. We used a few plugins for that. Then the final validation and final output for that we use satellite data and also some field outputs. Here is the result. We can see that the green spaces are the open spaces that we got from the model and the red ones are the buildings. So we can say that the model gave us pretty good result. And why we didn't use only the model from OSM, because sometimes we might not have the building. So we tried to figure out a way by which only we can use NDVI and NDVI to detect open spaces. And here you can see the road networks here, and after we implementing the model, it shows the route from where someone is to the nearest open space. So the contribution of this study to the resilience theory confirms that accessibility to open spaces, not just their existence, is a critical determinant of survival in earthquakes. So not only having open space, but knowing how to get there is important. Open size, it only use open source data and open source tools, participatory GIS, behavioral evidence. So that was all. Open mapping transcends a mere technical process. It is a profound theoretical and social practice for building resilience. This study demonstrated that detecting and routing to safe open spaces significantly reduces earthquake casualties by guiding people to safety during the critical initial moments of force shock. That's all from me. Thank you. I'm signing up. I'm sorry.
An example of how open source tools and OSM can be used to look for and maps safe spaces, especially in a very densely populated area like Dhaka in Bangladesh.